A family buys two policies from the same company. Losses on the two policies are independent and have continuous uniform distributions on the interval from 0 to 10. One policy has deductible of 1, the other has deductible of 2. The family experiences exactly one loss under each policy. Calculate the probability that the total benefit paid does not exceed 5. So one easy way to do it is to split it up in two cases. Mm, the first case would be, okay, first we let X to be the loss on policy, because the thing is that the distributions, the uniform distributions that we are given are for the loss, whereas the problem that we have to do is for the benefit, and the benefit is not quite the same as the loss because of the deductible. Uh, and we always call the initial variables to be the ones whose distributions are given. So since the loss distributions are given, so let X be the loss on policy with deductible 1 and Y be the loss on policy with deductible 2. And as we saw in the last problem, for uniform distributions, all you can do is you can just find the appropriate area that you need and divide that by the total area of the whole universe, which in uniform distribution will be a rectangle or a square. So here X is between 0 and 10, Y is between 0 and 10. Yeah, that's what both the loss variables were. And so the total area over here would be the length of this interval minus the length of this interval. So 10 times 10 be 100. And we are dealing with the situation where the total benefit does not exceed 5. So that's where I said that it will be helpful if we split it up into two cases. And case 1 is, so let's focus just on X. So case 1 is that X is between 0 and 1. So basically we're considering those cases where the total benefit could be less than 5. So when X is between 0 and 1, and the reason why we consider this one is that between 0 and 1, X doesn't pay anything because it's the deductible of 1. And then we just focus on Y. So then for the total benefit, so since there's no benefit for the first policy in this case, so the benefit from the second policy needs to be maximum 5. Remember, we are dealing with the total benefit being less than 5. So, and I'll be interchanging the less than and less than or equal to, and in continuous distributions, it doesn't matter. So, so total benefit to be a maximum of 5 means Y has to be between 0 and 7. Remember, Y has a deductible of 2. So if the loss under Y is 7, then the benefit under Y will be 5. So if the loss is from 0 to 7, then the benefit will be from 0 to 5 because of deductible of 2. So in this case, the total area involved will be, so X goes from 0 to 1, so that's a length of 1, and Y goes from 0 to 7, that's a length of 7, so the total area is 7. Case 2, X between 1 and 6. So why are we stopping at 6? X can actually go up to 10. The reason why we stop at 6 is that once X is more than 6, the X benefit alone becomes more than 5. Remember, X has a deductible of 1, and we are only considering the situation where the total benefit is less than 5. So that's why the X between 1 and 6 is our last case. So in this case, the benefit from the first policy will be X minus 1, right? Because of deductible being 1, loss is X. And the benefit from second policy needs to be less than, remember, total benefit needs to be less than 5. So second policy needs to be less than 5 minus the first policy benefit. So that's 6 minus X. So the second policy benefit needs to be less than 6 minus X. And since benefit is 2 less than the loss, so the loss has to be less than 8 minus X. So Y has to be less than 8 minus X. Remember, loss is always bigger than the benefit by the deductible. deductible is 2 for the second policy. So basically this is the main thing. We have to look what's happening at y is less than 8 minus x. So y is equal to 8 minus x is this line. So normally it will be the whole triangle over here for when you do y is less than 8 minus x, because less than 8 minus x will be the region below the y equals 8 minus x. But in this case, x is only between 1 and 6. So this is 1 for x, and this is 6 for x. I've indicated them here. 1 through 1, 7 means that this line has x equals 1, and this line has x equals 6. And since we are only between x1 and 6, so actually it ends up being this trapezoid. So this trapezoid area will be half times base times the sum of two heights. That's the formula for trapezoid area. So base is 6 minus 1, because this is 6 for the x and this is 1 for the x. So base is 6 minus 1. And the height is 7 plus 2. And we got this 7 and the 2 by putting the corresponding x values in this equation. So when x is 1, y is 7 from this equation. And similarly here, and x is 2, y is 6. So the height here is 7. Height is the y value, and the height here is 6. So the h1 plus h2 is, the height here is 2, the y value. So h1 plus h2 will be 7 plus 2. So that gives the total area of this trapezoid to be 22.5. And so the required area is the area of the trapezoid plus the area we got in case 1, which is 7. So that's 27 plus 22.5, that's 29.5. And the total area is 10 times 10, as we saw before here. So the required probability would be the required area over the total area, and that is 0.295, and that rounds to 0.3, which is choice C. Okay.